Hi everybody, welcome to the Manifold channel. Today we're going to take a look at phenomenal speed in Manifold. We're going to work with a vector data set of 22 million roads. We're going to look at all the roads in the United States. So let's move right on. We're looking at Manifold System Release 9. I'm going to click File, Open, and I'm going to open this project right here and click Open, and bang, it just opened up. That's over a 10 gigabyte project. And what do we have here? We have here a drawing, which is all the roads in the United States from the GDT data set. As you can see, it pans and zooms very quickly. There's so many roads that they kind of fill and they look black. I'm going to control click on that tab to zoom to fit. We're looking at them here in latitude and longitude projection. Now let's do something more interesting. We'll take that same data set and we'll open it up as a map. And here it is as a map. It's being reprojected on the fly into a pseudo-Mercator projection. And why are we doing that? It's so we can do things like add Bing Street Maps as a background layer. And I'll drag this layer above. So as you can see, what we're looking at right here is we're looking at that GDT layer where we're panning and zooming all the different, here's Washington, D.C. We're panning and zooming within the GDT map, and at the same time we're displaying on the fly a Bing Street Map. And we're reprojecting the GDT map from latitude longitude projection into a pseudo-Mercator. The Manifold is so fast at rendering even 22 million objects, and we can take a look here in the contents and see what it says. That's 21,900,000 roads, all the roads in the continental, lower 48, continental United States. Manifold is so fast that what it can do is it can actually display the road network faster than we can pull in tiles from the Bing server. So I'm going to turn off the Bing Map server. In fact, I'll just delete it from the map. And let's go back to, let's zoom to fit. Let's add a few other layers, and we'll add dots for streets that are 50,000 people and larger, and we'll add labels for those names. So now we can zoom around to look at various places and be guided by the labels. Here's Silicon Valley, Palo Alto, Mountain View, Sunnyvale, Santa Clara. That's where all our friends are at AMD and Intel, NVIDIA, and all those other cool places. Google's right over here in Mountain View. All the venture capitalists are here in Palo Alto, right about Sand Hill Road. That's right about there. And let's do something that's also interesting. What we can do is we can take, even though we're already looking at 22 million roads, let's take Boston, and here's an image of Boston at 13 centimeters. This is about I forget, I think it's about a 20 gigabyte image, something like that. And what we've done is we've linked it into the project so we can pan and zoom, look at Boston in just incredible detail, see individual people walking around in Boston Common. And I'm going to take that and I'm going to drag it and drop it into the same map as the GDT roads layer. So if we now, let's zoom to fit to the roads, and I'll right-click and drag to zoom. We'll right-click and drag to zoom here into Boston, and you can see there's so many roads in Boston that they tend to cover up that drawing, that image. But here we are, that full massive image that shows all of Boston in 13 centimeter resolution is right there, and we can pan and zoom all this stuff, even though we're panning and zooming in a map that has 22 million line objects in it, and also has all these other layers. And not only that, but it's actually reprojecting all this on the fly from latitude and longitude into pseudo-Mercator projection. It's doing all that so fast that you can really move as fast as you want, and there's absolutely no perception of slowdown. There's no halting, there's no display, it doesn't crash, doesn't do any of that. If you tried to do this with ArcGIS Pro or with QGIS, you'd absolutely die. You'd be waiting, I think, 5 or 10 minutes between each redraw of the screen. Well, maybe not that bad, but it would be unusable. Which brings us to this. So far, we're just panning and zooming, and you might think, okay, so what? You're panning and zooming, so that's all so well. But can you actually do anything with this vector data? And the answer is yes, we can. I deliberately opened up a version of this map that doesn't have Pennsylvania in there, so that we can do things like actually manipulate data. I'm going to pop up in another Manifold session here. Let's put it right here, and we'll do File, Open. Let's open up Pennsylvania. Here's the map with Pennsylvania in it. This is 1.7 gigabytes. I'm going to click Open, and it opens instantly. The cool thing about Manifold is when you use fast formats like Manifold.map format, it'll open up 10, 20 gigabytes of vector data absolutely instantly. Double-click Pennsylvania Open, and there it is, and that's 842,000 lines in all of Pennsylvania. Down here is, for example, Philadelphia. And what we're going to do with this is we're going to copy all these 842,000 lines, Control A for select all, and then I'll click here, Edit Copy. And that copies this to the clipboard. It only takes, less than 5 seconds to copy into the clipboard. And now I'm going to switch to this other manifold session here with the focus on the GDT rows layer, and I'm going to click Edit, Paste. And it's going to insert those 842,000 lines into the data set of 21,900,000 lines. And it doesn't take forever to do that. It does it remarkably quickly, and there it's done. And if we like, what we can do is we can actually save this now and see how long it takes us to save a map with all this cool structure in it. That's now well over, let's see how it is, well over 22,769,000 objects. Just click File, Save As, well, let's call it everything. Click Save. And because it's a key thing when you're actually saving stuff like this, how long does it actually take to save? And it's going to take a little, there it's already done already. So it took it that long to save a file. So when you're working with data with Manifold, it's just not a matter that it's unbelievably fast. It's also quite incredible that you can do things like find stuff and manipulate objects and actually edit these objects, even though you have over 22 million of them in that data set, and all that happens instantly. So let's do some more things. Let's see. I can't remember what all the FIPS codes are in here, but I do remember the Center County in Pennsylvania is that one. So let's pick one from one of the counties that we just added, and let's see. We're going to select where text contains, and the text field is the FIPS County, and where text contains that, and bang! You can see right away it selected all the roads in this. All the roads in Center County. What it's doing here is it's giving us a preview. That's actually not a full selection. The full selection, if we actually wanted to pull all those out of the database, we'd really have to go through the 22 million of them, and that would take us, probably as much as 10 seconds. But all the same, as you can see, man, to work with all this stuff this quick, and let's pick another county here, Madison County. I don't remember all the county FIPS codes, so I just put a few of them here that I could use for examples. Let's say text contains, and that's FIPS County, and text contains this. And that's Madison County in New York, right there. It's previewed for us in blue, and that's Butte's one of the lakes. I guess it's like Geneva or something like that near Syracuse. Well, whatever lake it is. Be that as it may, you can see how fast Manifold is. If you've just spent thousands and thousands of dollars for a license with ArcGIS Pro or something like that, and it's any slower than this, I think if you tried to open a vector layer with nearly 23 million line objects in it, it would choke ArcGIS. I know QGIS chokes. I've been trying to open this data set in QGIS all day, and it keeps crashing on me. It hasn't been able to open it. Maybe I'm doing something wrong. I'll see what I can. I'll keep working on it. But if you've worked with either of those products, or for that matter, any other vector GIS, you know that once you get past a couple million objects, it becomes intolerably slow. And working with this many objects is just it's just out of the question. It's just not realistic at all. Certainly not all the roads in the United States. You might ask, well, what is the computer that we're working with here? And let's take a look at Help About. We're working with what we now consider to be a mainstream professional GIS machine. Manifold traditionally has done video demos using really inexpensive gears, like $90 processors from 10 years ago, with the idea being to show people what you can do with really, really cheap stuff. This is a more mainstream machine. It's a $500 processor. An AMD Ryzen 9 is now about $500. List price is $499. There's still some price gouging going on because it's a very popular processor, but prices are dropping, and very soon I think it'll start selling, as processors always do, for well below list price. A GeForce GTX 1060 is a cheapo card. That's about a $170 card. This particular machine has 64 gigabytes of RAM in it, which I think these days you can pick up for about $250. And it's got a very inexpensive SSD. It's got only one SSD, a 1 terabyte SSD, and a M.2 slot. And that's a PNY SSD, which you can pick up for, I think, about $170 or about $200. So we're not talking about a $10,000 machine here. We're talking about a very, very middle-of-the-road machine with a $150 motherboard. That's really nothing special, and the sort of thing that anybody who's doing GIS on a professional or on a serious hobbyist basis can easily afford. And with that, you get the ability to do things which otherwise you have to spend thousands of dollars on to maybe do up in the cloud, maybe not do up in the cloud. I don't think Arc can do this work this fast, even if you put up everything up in the cloud. And I know alternatives like QGIS cannot, even if you keep all your data in very, very, very fast databases. So I hope you've enjoyed this demo. Give it a try. And thanks for watching. Goodbye from Manifold Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.